Boyle's law. And so that shows you that Boyle's law is in there. And now, what if the temperature does change? Right here, then what kind of law do we have? Alright, so if we take this law right here, I'm going to mark out the temperature for a moment. So what's left? And so P1 V1 equals P2 V2. And so what law was that? That was, ta-da, Boyle's law. And so that shows you that Boyle's law is in there. And now, what if the temperature does change, but we don't change something else? So next we have, notice if the pressure does not change, what do you get? So go up here, mark out the pressure this time, and we're left with V1 over T1 equals V2 over T2. And that's Charles' law. Alright, so what if the pressure and the temperature change, but what doesn't change now is the volume? So I'm going to go get a different color, mark out the volumes, and now we have P1 over T1 is P2 over T2, and that one is Gay-Lussac's law. So all three laws are combined in this one law right here. The thing is, in order for Gay-Lussac's law to be what we use, the two volumes would have to be identical, so they cancel each other out, or, you know, the two temperatures at the top or the two pressures. So you do need to be able to notice which one is which and be prepared. So now let's go on and look at how to use the combined gas law in a problem. Now, one thing that we talked about is the necessity of keeping the temperatures in kelvins, because you can't divide by zero. Remember that. And making sure that the pressure units are identical. And remember that I told you that on your test, and anytime, we're going to have this line of all the things that are equal to each other. So 1 atmosphere is equal to 760 millimeters of mercury, or 760 torr, or 14.7 psi. Here's a few others. So you can make conversion factors out of all these things. So what kind of conversion factors can we make? We could say 1 atmosphere is the same as 760 torr. See, 1 atmosphere is the same as 760 torr. Or opposite, 760 torr is the same as 1 atmosphere. Or we could say 14.7 psi, which is pounds per square inch, is the same as 760 millimeters of mercury. Or we could flip it upside down. So it's whatever the question needs you needs. You need to read it and see what happens. Okay, so let's go down here to this example problem. A gas has a volume of 3.6 liters. And remember, I always kind of circle it as I go. And it's under a pressure of 1.05 atmospheres and a temperature of negative 15 degrees Celsius. What is the new volume? There's the question. And at STP. So let's start off by putting all of our variables. We have the pressure, a volume, and a temperature. So here's the volume, 3.6 liters. And here's the pressure, 1.05 atmospheres, and the temperature is negative 15 degrees Celsius. And you'll notice I oftentimes put the temperature at the bottom because you're going to have to adjust the temperature to kelvins. But later on we're going to see we're going to have to adjust pressures as well. So there's no perfect reason to put them. You could have put V1 on top and P1 below it. It doesn't matter. So now it asks the question, what's the volume? So V2 then is the question, new volume. I need to know what the new volume is. And P2 and T2, well, what are they? They are standard temperature and pressure. Remember, I told you, you do have to memorize standard temperature and pressure. And so the standard temperature is 0 degrees Celsius, or also you could say 273 kelvins. Because remember that in order to convert to kelvins, kelvins is equal to 273 plus whatever Celsius. Well, if Celsius is 0, it's 273. So that's the standard temperature. So I'm going to go ahead and put 273 here, kelvins, because we have to use kelvins, because look at the temperature in the denominator. We cannot divide by 0. And then the standard pressure. Well, standard pressure is 1 atmosphere, or anything that's equal to 1 atmosphere. But since they used atmospheres here, 1 atmosphere is fine. Now, note this number, 1 atmosphere, and 273, these are definitions, so the sig figs do not depend on those. So now I'm going to set up the problem and solve for our unknown. First of all, I've got to change -15 to kelvins, so I add 273 to that, and see what we're going to get. And that gives us 258 kelvins. So now let's put it in the formula. P1V1 over T1 equals P2V2 over T2. Remember, you have to write the formula just like that to get a point. Put the values in. P1 is 1.05 atmospheres. V1 is 3.6 liters. T1 is 258 kelvins. We don't use the -15. I'm going to erase this a little bit. Get myself some room over here. Okay, P2 is 1 atmosphere. V2 is my unknown. And T2 is 273. Now, in order to solve these equations, I want you to cross multiply, because even the very best math student will make mistakes if they don't do this. So please go ahead and cross multiply. I'm going to set this up now for cross multiplication, okay? Okay, now I set it up. Notice we have 1 atmosphere times 3.6 liters times 273. And the second side, 258 kelvins times 1 atmosphere times V2. V2 is our unknown, so we need to isolate our unknown. So we're going to divide both sides by 1 atmosphere. And I forgot to put the unit atmosphere here. So 1 atmosphere and 258 kelvins. And you'll notice when I do it, I put the units right underneath the one they want to cancel out, just to help us to make sure. So kelvins and kelvins cancel, atmospheres and atmospheres cancel, and now we have V2 isolated, and we just have to plug in the numbers and figure out what our new value is going to be. So let me pull that up and do it. Okay, and what that gives us is 258, oh sorry, not 258, 3.99976, and the unit is liters. That's the only unit we didn't cancel out right here, liters. But now we have to figure out sig figs. Okay, in order to figure out sig figs, you got to look at the ones that were not the definitions. 1.05 is not a definition, 3 sig figs. 3.6 is not a definition, it's measured. Only 2 sig figs. And then 273 was a definition, because that was the T2, the standard temperature. 258 was not a definition, but that has 3 sig figs. And 1 atmosphere was a definition, it has 1, so our answer should have 2 sig figs. Okay, which is, you're going to have to be careful about that. Remember that the 1 atmosphere is standard temperature and pressure. So we're going to make this 2 sig figs to get 4.0 liters. Now, I would actually, since it says what will the volume be at standard temperature and pressure, the standard temperature and the pressure would be kind of measured, and I could understand then if you thought 1 atmosphere, so it would be a sig fig, and so 4 liters, I would probably be willing to take both of those answers. Okay, I hope this helps you. We're going to continue with Dalton's law of partial pressures the next time. So